Okay. Good evening to all of you. Are you able to listen my voice?
Yes, sir.
First, I am going to discuss the easy method to find a rank. Then I will discuss the previous questions. Questions asked in yesterday's class. Suppose repetitions are allowed, I am going to discuss it. So see this. Google. I want to find out the rank of Google. And what is the actual process we can do it, Nahash?
Sir, alphabetical order.
In alphabetical order. In alphabetical order, we should find out the number of words we can form it, and finally we reach to Google. Is it right?
Yes, sir.
So no need to write down the alphabet. Here we should write down the alphabetical order, but no need to start with the starting letter. So here, what is the letter comes in the first here in these letters?
E, sir.
E is having the rank 1. Is it right?
Yes, sir.
Next.
G.
So 2. This is also 2. Next.
L, sir.
3. This is 4, and this is also 4. Is it right?
Yes,
so
sir.
we should write down the ranks like this. In the English alphabets, so the letter which is in the first left hand side, so that having the higher rank. So based on that, according to that or otherwise, we can give the ranks like this. So what we should do here is, here with some gap I want to write, then easily we can understand. G, O, O, G, L, E is first rank, next third, this is second, fourth, second. Is it right?
Yes, sir.
Now what I do is, here I want to write down some number in the bottom of G. So observe this, how I am writing, you should observe very carefully. So if you remember this idea, we can find out the rank very easily. So right side to this letter, so how many letters having lesser rank than this? So how many letters to the right side of this letter having lesser rank with respect to this? How many are there?
1.
This
sir.
is greater rank, is it right?
Yes, sir.
So only one letter is there. So write down 1. Okay. Next. Here, O, always we should move right side only. We should move right side and we should observe right hand side only. So O. So here to the right side of this O, how many letters are there which are less than the rank 4? So
3,
this is
sir.
equal to, so this we should not consider 1, 2, 3. Next here.
3, sir.
3. This.
1.
1 here.
1.
Here.
0.
To the right hand side, we are not having no letters. So that's why no more letters are there. So 0. And one more thing we should write down in the denominator is by. Here, actually this number is purely based on 0 only. So including this to the right hand side, how many repetitions are there? That we should observe. Including this. So 2 G's, 2 O's are there. Is it right?
Yes, sir.
How many ways I can arrange it?
2 factorial into 2 factorial.
Denominator should write down. If I like things are there.
Sir, L key 2 ways, sir.
LK?
Number 2, sir.
Why?
Sir, kinda, sir. L kinda 1 and rasaru, sir.
Only 1 only. So right side to the L, how many letters having
Okay.
lesser than rank L?
Yes, sir, sir. Sir.
Only 1. So here 3 by, including this letter in the right hand side. Are there any repetitions? 2 O's? That's all. Is it right?
Yes, sir.
So 2 factor. By here, in L,
Right
with respect
side.
to this letter, we should move right hand side. And this letter also we should observe. Including this, is there any repetition?
No, sir.
So no need to write down the denominator. So 0 factorial, if you want to write down it. 0 factorial is 1 only. If repetitions are there, we can write down like this. Next, 1 by. Including this, are there any repetitions?
No, sir.
So no need to write down the denominator. Here,
No, no, sir.
here no. So if you want to write down by 0 factorial. So anyhow, 0 factorial is 1. And moreover, here the easy trick is write 0 factorial in the bottom of this. 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial. Write down like this. Into. So my answer is 5 factorial by 2 factorial plus 4 factorial into 3 by 2 factorial plus 3 into 3 factorial by 0 factorial. No need to write down. 2 factorial into 1 by 0 factorial plus 1 factorial into 1 by 0 factorial plus what is it? 0 by 0 factorial. Okay. In last, we should write down plus. So this is the number we are reaching it finally. So if we evaluate this whole value, we can get the mathematical rank of the word Google. Note down. If repetitions are not there, with repetitions here in denominator we are not getting any terms. Is it right?
Yes, sir.
So this is 120 by 4. 125 by 4 is 30. Next is 24 by 2, 12. 12 into 3, 36. Next, 3 factorial is 6. 6 3 is 18. 2 factorial is 2 into 1, 2. 1 factorial into 1, 1. That is 0, last one. Last but 1 is 0, last one is 1. Add these all numbers.
88.
Idanta? Total 88. So rank of Google is 80. అర్థమైంది తేజస్
అర్థమైంది సార్
ఏం చేయాలి మీరు ఫస్ట్ ఆఫ్ ఆల్ సో ఇన్ ద టాప్ ఆఫ్ ద గివెన్ వర్డ్ వీ షుడ్ అసైన్ ద ర్యాంక్స్ అంటే ఎలా అసైన్ చేస్తున్నాం మనం ర్యాంక్స్ ని
ఆల్ఫాబెటికల్ ఆర్డర్లో సార్
సో ఆల్ఫాబెటికల్ ఆర్డర్ వీఆర్ అసైనింగ్ ద నెంబర్స్ సో 1 2 3 సో ఆన్ లైక్ దట్ సో ఈ నెంబర్ ఎలా రాస్తాం చెప్పండి హౌ వీ కెన్ రైట్ డౌన్ దిస్ నెంబర్
సార్ జీకి రైట్ సైడ్
G ki right side. So we are not including G here.
Yes, sir.
So Z right side, how many
Less than
letters having lesser rank than this?
Then G. Yes, sir.
Than G. So how many? Only one is there. ఏదో ఒక వర్డ్ చెప్పే చేద్దాం ఎగ్జాంపుల్ another example, then we will discuss the problems. Nehas,
Sir.
ఏదో వర్డ్ చెప్పండి.
Recording.
ఏంటా? Recording. అంతేనా?
Yes, sir.
Are there any repetitions are there?
No, sir. No, sir.
Repetitions ఉన్నాయి చెప్పండి. Repetitions are not there, it's very easy.
సార్ రికార్డింగ్ లో ఉన్నాయి సార్ రిపిటేషన్ ఆర్
అవును సార్ ఆర్ ఉంది.
ఆర్ ఉంది అంటే 2 letters ఓన్లీ 2 letters are there. నలంద ఇంతేనా? ఇందులో 3 A's 2 A's ఉన్నాయి కదా.
Yes, sir.
ఇచ్చేయండి ఇప్పుడు ఏంటి ఆల్ఫాబెటిక్ లెటర్
1
1 1 1
2, sir.
2 3 4 4. డూ ఇట్ ఫాస్ట్. నాకు ఆన్సర్ చెప్పండి ఎంతమంది చెప్తారు చూద్దాం.
Sir, 390, sir.
390.
90.
No. జాగ్రత్త చేయండి క్యాలిక్యులేషన్.
Sir, 340.
3 ఎంత?
340, sir.
340 wrong. But you are nearby the answer. లాస్ట్ లో 1 యాడ్ చేయాలి, గుర్తుందా?
Oh, 1 minute, sir.
లాస్ట్ లో 1 యాడ్ చేశాను చూసారా? So here these values we are getting from multiplying these two. So after adding all the values, in last we should add 1. The answer anta. Srilikita.
Sir, 356 వచ్చి.
ఎంతండి?
356 sir.
No. Just a calculation మీరు చేయాల్సిందే. పూర్విత.
Sir.
ఎంత? What is the answer?
32.
ఎంతండి? 3
42 వచ్చింది సార్.
ఎంత మా ఆన్సర్?
342, sir.
342. Very good. 342 is correct. చాలా సింపుల్ అండి. ఇక్కడ ఎంత? రైట్ సైడ్ టు దిస్ how many letters are there? 1 2 3 4 5. Right side to this lesser rank 0. Here 1 2 3. Right side to this 0. Right side to this 2. Right side to this 1. Right side to this 0. Next by including this, how many repetitions are there? 2 n's, 3 a's. So 2 factorial, 3 factorial. by no need to write down this because 0 is there. 3 by rational no use and 3 by right side to this including only 2 a's are there, 2 factorial. Here no need to write down this by including this. Any repetitions are there? No. 0 factorial, 0 factorial, 0 factorial. No need to write down this. 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, 6 factorial. Here it's 0. This is 1 plus this is 4. No need to write down this plus 3 by 2 factorial into 4 factorial. And there 3 into 4 factorial is 24 by 2, 12, 36 plus 6 factorial into 5. 6 factorial is 720 into 5 by 2 into 6.
300, sir.
This is 6 factorial, sorry, 720, 60, 300 plus this is 40, 1 plus 1, 342. ఇంతేనా తేజస్?
ఎస్ సార్.
ఎక్కడ మిస్టేక్ ఎక్కడ చేసావు?
సార్ నేను అక్కడ అంటే ఎన్ పక్కకి 5, మీరు ఎన్ కింద 5 అని రాసుకున్నారు కదా సార్, నేను 5 కాకుండా 3 అని రాశాను సార్.
ఎందుకు
సార్ అంటే ఓన్లీ ఏసే కౌంట్ అంటే ఎన్తో కౌంట్ చేయలేదు సార్.
అంటే in the right side of n excluding this, how many letters having lesser rank than 4?
ఎస్ సార్, అంటే ఏ మొత్తం ఒకటే అనుకున్నాను సార్.
3, 4, 5 only we should write.
నేను ఏని ఒక మొత్తం ఏని ఒకటే అనుకున్నాను సార్.
లేదు total how many letters are lesser than rank 4?
ఎస్ సార్.
Okay, I hope all of you అర్థమైంది rank.
అర్థమైంది సార్.
Okay, next I move to the previous questions. ఒకసారి చూడండి, how many of you solved those yesterday's questions? ఎక్కడ రోజు చెప్పుకున్నా మనం నేహస్?
Sure, నిన్న minimum is 3 and maximum is 7. ఆ క్వశ్చన్
అయిపోయింది కదా. నెక్స్ట్ క్వశ్చన్, minimum is at most 3. So what are the answers you had for this question? Answers ఏం వచ్చినాయండి? మినిమం ఈజ్ అట్ మోస్ట్ 3. నేహాజ్ ఏం వచ్చింది నీకు?
3 to power 5 వచ్చింది.
ఎంత?
3 power 5.
3 power 5. ఓకే, శ్రీలిఖిత
3 power 5 sir.
శ్రీలిఖిత
Sir,
మినిమం ఈజ్ అట్ మోస్ట్ 3.
3 power 5 వచ్చింది.
3 power 5 వచ్చింది, రాంగ్. నెక్స్ట్ రిషిత్
సార్ రిషిత్ కి సిగ్నల్ ప్రాబ్లం అవుతుంది సార్.
ఓకే, నెక్స్ట్ సంహిత
సార్ 3 power 5 అనుకున్నా సార్.
ఓకే, పూర్విత ఏమో
7 power 5.
ఎంతండి?
7 power 5.
You are saying answer is 7 power 5?
Yes sir.
ఎవరు చెప్తుంది? పూర్వితనా?
No sir.
ఎవరు?
శ్రీలిఖిత.
కాదండి. నేహాస్ ఎందుకు 3 power 5 అన్నావు?
అంటే మినిమం నెంబర్ అట్ మోస్ట్ 3 ఉన్నాం.
అవును,
అప్పుడు 1, 2, 3 ఆ 3 నెంబర్స్ ఉంటాయి. ఆ 3 నెంబర్స్ ఉంటాయి.
ఆల్ నెంబర్స్ నీడ్ నాట్ బి 1, 2, 3. వాట్ దే ఆర్ సేయింగ్, మినిమం నెంబర్ ఇన్ దోస్ 5 draws షుడ్ బి at most 3. అర్థమవుతుందా? ఆర్ యు అండర్స్టాండింగ్?
Yes sir.
1, 2, 3, 4. Minimum number in this 5 draws is at most 3. అంటే the number 7 also may comes.
Yes, sir.
7 రావచ్చు, 8 రావచ్చు, 9 రావచ్చు, but here so all are greater than 3, right? So here
Yes, sir.
my required event is minimum is at most 3. So here I can write 3, 2, 1. So that is automatically minimum is at most 3. Avuna kada?
Yes, sir.
So that cases we are not considering. Yeah, Tejas,
Sir,
answer
10 power 5 minus 7 power 5, sir.
10 power 5 minus 7 power 5. Why?
సార్ మినిమం ఈజ్ అట్ మోస్ట్ 3 అంటే అక్కడ మీకు మాక్సిమం కి లిమిట్ లేదు సార్. ఎంత
Okay,
ఎంత
very good. Minimum is at most 3 ante is not saying limit for the maximum number. Okay.
ఎస్ సార్. దాని తర్వాత దాని కాంప్లిమెంట్ కేస్ కన్సిడర్ చేసి మొత్తంలోకి వెళ్ళి ఈ కాంప్లిమెంట్ కేస్ సబ్ట్రాక్ట్ చేస్తే మనకి అట్
In
మోస్ట్
complement and what is the complement of this Purvita? Minimum is at most 3. What is its complement? Purvita?
Sir,
Minimum is at most 3. In the 5 draws, minimum number drawn is at most 3. So what is its complement event? Complement and negation event. Negation of the statement.
at least 3 అనుకో.
So minimum will be the same only. Our condition is on minimum number only. Minimum is at most, we are saying at most 3. At most 3 means what are the possibilities of a minimum number? Either 1, 2, 3. Is it right?
Yes, sir.
Mari, what are the remaining possibilities we are having?
4, 5.
So the minimum number is either 1, 2, 3. So this complement is this only. Is it right?
Yes, sir.
So what I should say in statement form? Minimum is at least 3 or at least 4.
4, 4.
Very good. This is the complement of this. Minimum is at least 4. Ante kada? If we subtract minimum is at least 4 from the total cases, we will get minimum is at most 3. Is it right, Nahas?
Yes, sir.
What are the total cases we are having? In this draw, I can have 10 chances. In this draw, I can have 10 chances. So total 10 power 5 minus. Yen subtract cheyali ipudu.
Minimum is at least 4.
Minimum is at least 4. Ante definitely in these 5 draws, I have to get the numbers from ఎక్కడి నుంచి ఎక్కడికి రావాలి?
4 నుంచి 10 దాకా.
ఎక్కడ వరకైనా రావచ్చు. 4, 6, 7, 8, 9, 10. అంటే in these 5 draws, definitely to satisfy this event, I should get the only numbers 4, 5, 6, 7, 8, 9, 10. We should get it in these 5 draws. So how many numbers are there here?
Sir, 7.
So for this draw, 7 possibilities, 7, 7, 7. So 7 power 5. So Tejas answer is correct only. ఏమమ్మా శ్రీలిఖిత నువ్వు రివర్స్ చెప్పు ఎగ్జాక్ట్లీ.
Yes, sir.
అర్థమైంది ఇప్పుడు నీకు?
Yes, sir.
నాకు ఇప్పుడు నెక్స్ట్ క్వశ్చన్ ఆన్సర్ సంహిత చెప్పాలి. Samhita, what is the next question?
Maximum is at least 7, sir.
Maximum is
At least 7.
at least 7. అంటే దీన్ని this problem we can do it in another way also. దీన్ని ఇంకో వేలో కూడా చేయొచ్చండి. Minimum is at most 3. What are the possibilities in this we are having? Minimum is 1 or minimum is 2 or minimum is 3. Is it right, Nahas?
Yes, sir.
Intena? I think only these three possibilities we are having. Anything else, Samhita?
No, sir.
Only these three possibilities we are having in minimum is at least 3. So minimum one, how many possibilities? And our event of getting minimum number is at most 3 can happen in 3 possibilities. One is minimum number can be 1, or another possibility is minimum number is 2, or another possibility is minimum number is 3. ఇక్కడ minimum అంటే ఏంటంటే minimum number in all the 5 draws. Is it right? అవునా కదా నేహాస్?
Yes, sir.
ఇప్పుడు how many ways we are having for minimum is 1? చెప్పండి చూద్దాం. అంటే నాకేమవ్వాలి, in 5 draws, however the numbers are present in these 5 draws, but minimum number should be
1.
చెప్పండి ఎన్ని possibilities we are having?
Sir, 10 power 5 minus 9 power 5.
ఎలా చెప్పావు?
అంటే సేమ్ ఇందాకట్లాగానే సార్, దాని కాంప్లిమెంట్ ఈవెంట్ తీసుకొని
కాంప్లిమెంట్ ఈవెంట్ ఏంటి అసలు? మినిమం 1 అంటే వాట్ ఇస్ ఇట్ మీన్స్?
తీసిన 5 draws లో మినిమం నెంబర్ 1 అయి ఉండాలి.
అంటే ఏం చేసాం?
అంటే 10 numbers లో మినిమం నెంబర్ 1 అయి ఉండాలి. సో మాక్సిమం నెంబర్ ఏదైనా అవ్వచ్చు సార్.
అవును.
మొత్తం పాసిబిలిటీస్ లోంచి
అంటే వాట్ ఈస్ ద మీనింగ్ ఆఫ్ మినిమం 1?
అంటే ఒక్కసారి తీసిన ప్రతి పాసిబిలిటీలో 1 అనే నెంబర్ రావాలి.
అంటే టోటల్ నెంబర్స్ లో వాట్ ఆర్ ద టోటల్ నెంబర్ ఆఫ్ వేస్?
10 power 5.
10 power 5. In this 10 power 5 minimum 1 అంటే what does it means?
Minimum number should be 1 in the
if
possible.
At least one present, then definitely minimum number should be 1. Is it right?
Yes, sir.
But in this all 10 power 5 ways, is at least one present in all the 10 power 5 ways?
No, sir.
No. So what we should subtract from 10 power 5?
Minimum number 1 కానిది
అవసరం లేదండి. 1 అని కాదండి, ఇక్కడ మీరు చాలా జాగ్రత్తగా అబ్జర్వ్ చేయాలి. వాట్ ఐఎమ్ సేయింగ్, ఇఫ్ at least one present, at least one present in this 10 power 5, then automatically minimum number is 1. Is it right?
Yes, sir.
To get this event, what we should subtract from this? At least one present. What is the complement of that? At least one present. What is the complement of that, or what is the negation of that statement? And what are the possibilities of 1? 1 can occur 0 number of times. 1 time, 2 times, 3 times, 4 times, 5 times. Is it possible to get 6 times?
No, sir.
Because we are having 5 draws only. What is my statement? 1 can occur in at least 1 time.
1 time.
And 1, 2, 3, 4, 5. What is the complement of this? This complement.
1 cannot occur.
Adi, that we should say. So 1 should not appear in this 5 draws. In how many ways 1 should not appear in the 5 draws? So it means in each draw, we should get the outcomes from 1, 2 to 9, 2 to 10. Is it right?
Yes, sir.
How many possibilities are there?
9 possibilities.
And what is the answer?
10 power 5 minus 9 power 5.
And this is what minimum drawn is 1. ఇక్కడ R అన్న, R అంటే మీనింగ్ ఏంటి? ప్లస్.
ప్లస్.
అంతే కదా?
Yes, sir.
అంటే ఎందుకు? మినిమం at most 3 can happen in minimum 1 or minimum 2 or minimum 3. It's an addition principle. Already in counting I discussed it. Addition principle, multiplication principle. అర్థమవుతుందా? why I am adding this?
Yes, sir.
ఎందుకు? our required event can occur like minimum 1,
minimum 2 or minimum.
And the minimum 1 possibilities I counted it. Minimum 2 we should count down. Minimum 3 we should count down. So it means our required event can happen in any one of these 3. Is it right?
Yes, sir.
ఇప్పుడు చూడండి, how many ways we are having for minimum 2? Minimum 2 అంటే meaning ఏంటి? Minimum 2. What does it means? Our minimum number should be 2.
Should be 2.
So total numbers coming in all the 5 draws should be lies between 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it right?
Yes, sir.
So how many ways are there for each draw?
See,
2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 slips are there. 1 slip I excluded.
9, sir.
How many chances? 9 power 5.
9 power 5.
In all the 9 power 5 ways, is minimum is 2?
No, sir.
But what we should subtract?
Minus, no 2 should come.
2 is not present in this 5 draws. 2 is not present means how many ways are there?
8 power 5.
Same way, this way, if we simplify it, 8 power 5 minus 7 power 5 will get it. What is the answer?
10 power 5 minus 7 power 5.
Like this also we should do. Tejas, అర్థమైంది ఇది?
అర్థమైంది సార్.
Samhitana?
Yes, sir. Sir, 10 power 5 minus 6 power 5, sir.
10 power 5 minus
6 power 5.
ఇది ఏ క్వశ్చన్?
Maximum is at least 7.
నాకు వినపట్లేదు. Say loudly.
Maximum is at least 7, sir.
Maximum is at least 7. So 10 power 5 minus, what is the complement event of this? Maximum is at most 6. ఇంతే కదా?
Yes, sir.
Maximum is at most 6. So what are the numbers we should have? 1, 2, 3, 4, 5, 6. So 6 power 5. Okay, very good. But if you want to do it in another way, how I can do it? ఎలా చేస్తారు? సమితి ఎలా చేస్తారు? వేరే వేలో. Maximum is at least 7 అంటే maximum is 7 plus maximum is 8.
Maximum 9, maximum 10.
10. Add all those cases. Is that good? Fan off. Fan off, sir. నెక్స్ట్ క్వశ్చన్ చెప్పండి. తేజస్ చెప్పండి నెక్స్ట్ క్వశ్చన్.
సార్ మినిమం ఇస్ at most 3 and maximum is
at most 3 and
maximum is at least 7.
At least 7. ఏం చేస్తారు చెప్పు.
సార్ ఇంటర్సెక్షన్ కనుక్కోవాలి సార్ మనం. సార్ టోటల్ కేసెస్ అయితే 10 power 5 వస్తాయి సార్.
ఇప్పుడు దీన్ని అంటే ఇప్పుడు 2 ways లో చూస్తామండి ఎప్పుడైనా కానీ. If you want to count down the required event as it is, it's going to be difficult. Then we should consider the complement.
Yes, sir.
And sometimes finding the number of ways of a required event as it is, it becomes easy. And as it is, and the meaning and as it is counting the required event, it's better than counting the complement event.
Complement. Yes, sir.
Sometimes counting complement event is easy. అర్థమవుతుందా?
అర్థమైంది సార్.
ఇప్పుడు minimum is at most 3 and maximum is at least 7. So first of all, understand how the numbers and how the draws will be. how we are getting the draws? Minimum is at most 3. And the minimum number either it should be 1, 2, 3. Is it right?
Yes, sir.
Maximum number is either 7, 8, 9, 10. So what about the remaining numbers? Remaining numbers can be anything.
Yes, sir. Between 3 to 7.
Minimum is at most 3. Maximum is at least 7.
Yes, sir.
And he is not saying the remaining numbers.
Yes, sir.
And the actual cases, how we should do? Minimum 1, maximum 7, minimum 1, maximum 8, minimum 1, maximum 9, minimum 1, maximum 10, minimum 2, maximum 7, minimum 2, maximum 8. So total 3 into 4, 12 possibilities you should write down.
Yes, sir.
So if we can add those all 10, 12 possibilities, 10 ఏంటి చెప్పండి? Minimum 1,
Maximum 7.
తర్వాత 1, 8,
1, 8,
1, 9, 1, 10, 2, 7, 2, 8, 2, 9, 2, 10, 3, 7, 3, 8, 3, 9. ఇవన్నీ 12 కేసెస్ కౌంట్ చేసి ఏం చేయాలి?
యాడ్ చేయాలి సార్ అన్ని.
యాడ్ చేయాలి. వెరీ గుడ్. బట్ ఇట్ లుక్స్ లైక్ వెరీ డిఫికల్ట్. అవునా కదా?
ఎస్ సార్.
బట్ ఐడియా మనకు వస్తుంది అనమాట. దీని కాంప్లిమెంట్ ఈవెంట్ ఒకసారి ఏంటో చూద్దామండి. వాట్ ఈస్ ద కాంప్లిమెంట్ ఈవెంట్ ఆఫ్ దిస్?
మినిమమ్ ఈస్ అట్లీస్ట్ 4.
మినిమమ్ ఈస్
అట్లీస్ట్ 4.
మినిమమ్ ఈస్ అట్లీస్ట్ 4 అండ్ వదిలేసాను. What is the complement of this symbol? I will discuss it slowly. So this statement negation is this, and this statement negation is
minimum is maximum is at most 6.
Very good. So if I am calling this event as A and this event is B, then this is going to be A complement and this is B complement. What we should find out here?
Intersection.
N of A intersection B. Is it right?
Yes, sir.
What is N of A intersection B? Total cases minus N of complement of this. Is it right?
Yes, sir.
What is complement of this? This formula I discussed it.
A complement
intersection will be union B complement.
B complement. Yes, sir.
So total cases 10 power 5 minus. Can I apply Venn diagram formula?
Yes,
De Morgan laws. These are called De Morgan laws. What is N of A complement? Can you find out this? Minimum is at least 4. Can you count on this very easily?
Yes, sir.
Inni? Yeah, Nahas nu cheppali.
Sir.
Minimum is at least 4. In 5 draws, minimum is at least 4.
7 power 5.
Entane? 7 power 5 plus. Idi. Minimum is at least 6. Samhita మీరు చెప్పండి. Maximum is at least 6.
5 power 5, sir.
Very good. At most 6.
Sir?
Maximum is at most 6.
6, sir.
Enta?
10 power 5 minus?
No. See this. Maximum is at most 6.
5 power 5, sir.
At most 6 I am saying. 6 is also there.
4, 6, 7, 8, 9.
No. Maximum is at most 6.
6 power 5, sir.
6 power 5. Because our number should belong to 1 to 6. Is it right? 6 power 5. Then what is this? Nahas?
Minimum is 4 and maximum is at most 7.
Minimum at least 4, maximum at most 6. And all the numbers should belong to
4, 5, 6.
4, 5, 6. How many ways are there?
3 power 4.
3 power 5. This is my answer. No doubt. నేను సర్క్యులర్ నుంచి రేపు చెప్తానండి. ఎందుకంటే రిమైనింగ్ ఫ్యూ క్వశ్చన్స్ ఆర్ దేర్ రిగార్డింగ్ దిస్ పెర్ముటేషన్స్ అండి. Next question ante Tejas.
So the minimum is 3 or maximum is 7.
Minimum is 3 or maximum is 7. ఏం చేస్తారండి ఇది? Minimum definitely should be 3. Maximum at least maximum should be 7.
7. Yes, sir.
And moreover, minimum 3 or maximum 7. And no need to occur both the events. If at least one event is occurring, we can say, so this A or B occurring. So A or B occurring, it means A can occur or
B can occur.
B can occur. Need not A and B to occur together. Until first of all, define the events. This is A, suppose.
A. Yes, sir.
This is B. What we should find out here?
A union, N of A union B.
Then what is N of A union B?
N of A plus N of B.
So definitely we should not do with complement, because minimum is 3. They mentioned it.
Yes, sir.
So what is its complement? Minimum is not 3.
Yes, sir.
So considering complement, it becomes very lengthy. Don't go in the complement way here.
Ardhamayindi, sir.
Minimum is not 3. It means 1, 2, 4, 5. All the ways we should consider. N of B minus N of
intersection.
What is N of A?
8 power 5 minus 7 power 5.
And iదేంటి అసలు చెప్పు. What is N of A? Minimum
is 3. Yes, sir.
And minimum is 3 and anta
8 power 5 minus 7 power 5.
ఎందుకు? At least 1 3 present.
Yes, sir.
Maximum is 7. అమ్మ శ్రీలిఖిత చెప్పండి. Maximum is 7. శ్రీలిఖిత. సంహిత. సంహిత. Samhita, are you there? Purvita. Purvita. Nehas. Maximum is 7. ఏం చేస్తారు?
Maximum is 7
అంటే చూడాలండి. Maximum is 7 అంటే what should be the outcomes of the draws? 1 2 3 4 5 6 7. Is it right? Yes. So total how many cases? 7 power 5. All the 7 power 5 having the property of maximum 7?
No.
Minus what we should subtract?
6 power 5.
Ante. Minus N of A intersection B.
5 power.
ఇది ఇక్కడ చాలా జాగ్రత్తగా అబ్జర్వ్ చేయాలి. Minimum is 3 and maximum is 7. అవునా కదా?
Yes, sir.
ఏం చేస్తారు?
5 power 5.
Huh?
5 power 5.
Is 5 power 5 is correct? Nehas? Tejas?
No, sir.
Minimum is 3, maximum is 7. And the meaning ఏంటి? So in the 5 draws, we should get the numbers from 3, 4, 5, 6, 7. But he is saying minimum is 3 and maximum is 7. And at least 1 3 present, at least
1 7%.
Adi correct. And total you are saying 5 power 5. In this 3 not present also we are counting it. But at least 1 3 present should at least 1 3 present. Is it right?
Yes, sir.
At least 1 3 present, at least 1 7 present.
Mhm.
So in this number of ways, what we should subtract it? 3 is not present. Avuna kada?
Yes, sir.
7 is not
Seven,
present. 3 not
sir.
present. How many ways?
4 per 5.
7 not present.
4 per.
But in this 3 not present, 7 not present is there. In this 3 not present, 7 not present is there.
Yes, sir.
How many times we are subtracting 3 not present, 7 not
2
present?
times.
2 times. But how many times we should subtract?
1 time only.
So add 3 and 7 not present.
3 per 5.
3 and 7 not present. So this is the answer. No doubt.
Sir, sir, minimum 3, maximum 7 అది ఇంకోసారి ఎక్స్ప్లెయిన్ చేస్తారా?
ఈ క్వశ్చనే కదా మీరు చెప్పింది.
Yes, sir.
Minimum maximum 7 అంటే this I am defining A, this I am defining B. N of A union B, we should find it N of A plus N of B, N of A intersection B. ఎక్కడ అర్థం కాలేదు నీకు? ఇదా?
సార్ ప్రీవియస్ గా కొంచెం నెట్ సరిగ్గా లేదు సార్.
ఓకే, పర్లా నువ్వు అంటే ఎక్కడ నీకు ప్రాబ్లం చెప్పండి.
మినిమం 3, మాక్సిమం 7 సార్. అది 8 పవర్ 5 మైనస్ 7 పవర్ 5 అది ఎలా వచ్చింది?
ఇదేంటి యాక్చువల్లీ వాట్ ఈస్ N of A?
మినిమం ఇస్ 3 సార్.
సో ఇన్ హౌ మెనీ ఇయర్స్ వీ కెన్ గెట్ మినిమం 3? మినిమం 3 అంటే మీనింగ్ ఏంటి? సో ఇన్ ఆల్ ద 5 draws we should get the outcomes definitely should be greater than or equal to 5. Is it right?
Yes, sir.
So what are the possibilities for this? 8 because 3 to 10, right?
Yes, sir.
This 8, this 8, this 8, this 8, 8 power 5. ఇక్కడ మీరు అబ్జర్వ్ చేయాల్సిందంటే in all 8 power 5s minimum is 3. No, because here I am writing 8 ways. It means any one of these 8 may occur. So suppose here 4 is occurring, 4 is occurring, 4 is occurring, 5 is occurring. Is it satisfies minimum 3?
No, sir.
So such cases are also there in the 8 power 5.
Yes, sir.
So మరి ఏం సబ్ట్రాక్ట్ చేయాలి? Minimum is 3. అంటే at least one time 3 should present. That we should find out.
Yes, sir.
In our 5 draws, if at least 1 3 is present, suppose 3 is present, can you say minimum is 3 here?
అంటే ఒకసారి 3 ఉన్నప్పుడు. Yes, sir. Present, sir.
Here 3 present. Can I say at least, at most, at least minimum is 3? ఇక్కడ suppose 7 and ఇక్కడ 3 ఉంది అనుకోండి. Here also can I say at least minimum is 3?
Yes, sir.
అంటే మీనింగ్ ఏంటండి? At least one time 3 should present.
Yes, sir.
So in all the cases of 8 power 5, at least 1 3 need not present always.
Yes, sir.
And ఏం చేయాలి? To get this number of ways, we should subtract what is the complement event of at least 1 3 present.
ఒకసారి కూడా 3 రాకుండా.
And 3 not present. And
Yes,
cancel this. With remaining, how many outcomes are there?
7.
7 power 5. That only I have written.
Okay, sir.
That is minimum 3. Okay, no?
Yes, sir.
Remaining చేస్తారా? Remaining 2 questions మీరు తేజస్?
ఎస్ సార్.
మీరు ట్రై చేయండి. ఇక్కడ నేను చెప్పేస్తానండి circular permutations. Then I will discuss those questions because those are related to the combination also. Put this side heading. Circular permutations. Just only basics I will discuss in today's class. Circular permutations. Teja, circular permutation అంటే ఏంటండి?
అంటే arranging in circular order.
We should arrange the objects in the circle. అవునా కదా?
Yes sir.
Suppose with the example I am trying to explain it. Suppose I want to arrange 3 objects symmetrically. Suppose the objects are not symmetric. There is and it's not a beautiful thing anamata. Why it's not a beautiful thing? Slowly you can understand it. So here objects is also should be symmetric, because what is the whole angle? Total angle
360.
2 pi at the center.
Yes sir.
So symmetrically are there, then arrange it. If they are not symmetric, if they are not symmetric, suppose A is here and B is here, C is here, with the distance we can treat it as another arrangement. Is it right?
Yes sir.
Suppose A, B, C, it looks like different arrangement by keeping B here. Okay?
Yes sir.
So symmetrically we should arrange it here, maximum cases. Okay. But then how I can arrange it in circular ABC? Suppose there are 3 persons ABC. These 3 persons I want to arrange it. Suppose 3 letters are there. Suppose 3 letters are there. And moreover, first of all, I am going to discuss distinct objects arrangement in circular. So what are the alike objects? Slowly you will learn. ABC, suppose 3 distinct letters are there. How many ways I can arrange in linear?
3 factorial ways.
So what are the ABC? Next.
ACB.
BCA. First one I want to keep it. ABC. Next. ACB. Next.
BCA.
BCA. BAC. Next. CAB. CBA. So total how many ways are there? 6 factors. Now I want to interrelate the number of circular permutations with linear permutations. Then easily we can understand. So observe this. So this circular permutation I am considering by observing this linear permutation, because whatever the first one is there, that I want to keep it in the top. So the next one I want to keep it in the right. So the last one I want to keep it in the left. Okay?
Okay sir.
You following my point?
Yes sir.
Next, this arrangement I want to draw. Observe it carefully. What I should draw? Circular permutation corresponding to this. B, C, A. Is it right?
Yes sir.
Next I will come to this arrangement. Are you following my point?
Yes sir.
Next, C, A, B.
B.
So second element I want to write it in the right hand side. Last element left hand side, and the first element on the top. Like this I want to write down. Then it is easy to count down the cases easily. Next I will come to this. A. Next chapter. C,
B.
Next this. B,
AC.
AC. Next
CBA.
C,
BA.
Can you say any relation between these 3 arrangements?
Same sir, they are same.
They are same. Why they are same? A neighborhoods are B and C, and suppose A left neighborhood is B, right neighborhood is C. Here also A neighbors are same. Is it right?
Yes,
Otherwise,
sir.
rotate this figure basically. So I want to keep the positions as it is here. I want to rotate the positions actually. A comes here and B comes here, then C comes here. This arrangement. Okay.
Yes, sir.
So observe this: A, B, C. Here A, B, C. Here A, B, C. Is it right?
Yes, sir.
So these three arrangements are clearly
Equal, similar.
same.
Yes, sir.
And these three arrangements we should treat it as same circular arrangement. Is it right?
Yes, sir.
అర్థమవుతుందమ్మా శ్రీలిఖిత?
Sir.
అర్థమైందా? నేహాస్
అర్థమైంది సార్.
ఇప్పుడు ఈ రెండు చూడండి. వాట్ యూ కెన్ సే అబౌట్ దీస్ టూ కెన్ యూ సే ఇట్ as సేమ్ ఆర్ డిఫరెంట్? అబ్జర్వ్ దిస్. హియర్ ABC clockwise, here ABC
యాంటీ క్లాక్ వైజ్.
so it means A right neighborhood and left neighborhood are different from A neighbors here. అవునా కదా?
ఎస్ సార్.
A right neighborhood and left neighborhood are different in this arrangement and compared with this. ఇక్కడ A right neighborhood suppose B, here A right neighborhood is
C.
so these two arrangements are different clearly. So these two are not same. అవునా కదా? ఇక్కడ ఈ రెండు చూడండి. దీస్ టూ ACB clockwise, here also ACB. అంటే నేను వాట్ ఐ కెన్ అండర్స్టాండ్ ఇన్ ద సర్క్యులర్ పెరిమిటేషన్ దేర్ ఈస్ నో స్టార్టింగ్ పాయింట్. ఇస్ ఇట్ రైట్? అర్థమవుతుందా తేజస్?
Yes, sir.
So I can start from arranging the objects from this point, or I can start the objects arranging from this point.
Yes, sir.
So because this ACB and this ACB are same, so that's why in the circular permutation there is no
Starting point.
starting point. ఇక్కడ చూడండి ACB. So clearly these three are identical, these three are identical. అర్థమవుతుందా?
Yes, sir.
అంటే how many circular permutations we are having?
2, sir.
ఇక్కడ చాలా జాగ్రత్తగా అబ్జర్వ్ చేయాలి. How many copies we are having? How many duplications we are having?
3, sir.
3 duplications we are having. Here 3 duplications, here 3 duplications. Why we are having only 3 duplications? Because we are having 3 objects.
Yes, sir.
If we consider n objects, how many duplications we can have?
N, sir.
N duplications. Because rotate like this. A, B, C is there. A is here, then B automatically goes to this place and C automatically goes to this place. So if we n objects, we can rotate to n, we can rotate n times and we can form n duplicatives. అర్థమవుతుందా?
Yes, sir.
సపోజ్ AB ఇలా ఉన్నాయనుకోండి. సపోజ్ ABCD. ABCD. How can form duplicatives?
By rotating.
ABCD. Next. ABCD. Next. ABCD. How many duplicatives are there?
4, sir.
So ఎందుకు? Because we have
4 objects.
4 objects. So suppose n objects we are trying to arrange. How many duplicatives I can form?
N, sir.
N duplicatives. అవునా కదా?
Yes, sir.
చాలా జాగ్రత్తగా అబ్జర్వ్ చేయాలి. ఇక్కడ here. So finally your answer is how many circular permutations are there?
2, sir.
2 circular permutations are there. Is it right?
Yes, sir.
So it means so what about total linear permutations? 6 factorial.
3 factorials.
So sorry, 3 factorial, 6 factorial. So total permutations, circular linear permutations, 3 factorial
by 3.
చాలా జాగ్రత్తగా అబ్జర్వ్. 3 factorial. With this 3 factorial, if you write all linear permutations, we can have n duplicatives. Is it right?
Yes, sir.
So here 3 factorial is there. So 3 duplicatives are there. So 3 duplicatives and these 3 I am considering as 1. So
Yes,
these
sir.
3 I am considering as 1. So to get the circular permutations, what I should do?
By.
By 3.
Yes, sir.
And suppose if you are having n distinct things arranged in a circular permutation, What about number of ways?
n factorial by n, sir.
Very good. అది రాసేస్తాను అన్నమాట ఇప్పుడు డైరెక్ట్ గా. And moreover, one thing we can understand is in circular permutation there is no
Starting point.
starting point. Note down this. Number of circular permutations with n different things. Number of circular permutations with n different things. ఎంత
n factorial by n.
అదెంత n minus 1 factorial. ఈ ఎగ్జాంపుల్ ఒకటి నోట్ చేసుకోండి. ఈ ఎందుకు ఈ n?
Because that many duplicatives. Yes, sir.
Duplicative sequence or duplications. అంటే 2 ఆబ్జెక్ట్స్ ని సర్కిల్ గా ఎన్ని వేస్ లో అరేంజ్ చేస్తా?
One way, sir.
ఎందుకు? Symmetrical if we arrange it, AB is same as that of BA. Is it right?
Yes, sir.
Circle it's one only. అంటే ఇలా చెప్పొచ్చు, the number of ways of arranging n different things in circular, and it's called circular permutation only. How many are there?
n factorial by n, sir. n minus 1 whole factorial.
n minus 1 whole factor. Now ఇక్కడ నెక్స్ట్ అండి, ఇట్స్ వెరీ వెరీ ఇంపార్టెంట్. If the circular permutation can be seen from both the sides, then the number of circular permutations is ఏమవుతా? ఒకసారి చదువు.
If the circular permutations can be seen from both the sides, then the number of
permutations can be seen from both the sides, then the number of circular permutations is ఎంత చెప్పగలరా? అంటే బోత్ సైడ్స్ అంటే మీనింగ్ ఏంటండి? ఇప్పుడు సపోజ్ this arrangement I'm seeing from the front side, it looks like ABC. Is it right?
Yes, sir.
If we have chance of observing this circle on another side, it means backward.
Yes, sir. ACB.
Then this and this are same. Is it right?
Yes, sir.
అర్థమవుతుందా నేను అనేది?
అర్థమైంది, sir.
If you can see the circular permutation from both the sides, so suppose front side it looks like this, so back side this arrangement looks like this. Avuna kada?
Yes, sir.
Then these two circular permutations we can consider as same. If you can see from both the sides, so that's why how many such arrangements you can have? So for this we can have one correspondence, so half of them will be there. Is it right?
Yes, sir. And yes, sir.
So 2 pairwise we should treat it as same. Avuna kada?
Avunu, sir.
And moreover, these two are what? This is clockwise, this should be anti-clockwise.
Yes, sir.
Observe this. This is BCA, this is BCA. So observing this and this from both the sides, they appear as same. So seeing this from front side, seeing this from the back side. So both are same. And eppudandi, when we can use this type of logic, if the circular permutation can be seen from both the sides. Suppose the problem is related to the garland. Pola mala antaru, or necklace beads. Tejas,
sir.
In necklace we can see him from both the sides, is it right?
Yes, sir.
So garland is also we can see him from both the sides. Suppose you want to arrange 10 people in a circular table, we can't see it on both the sides.
Yes, sir.
So this time we should not write by 2. Ante kada?
Yes, sir.
One circular table conference lo, then I have to arrange 10 persons. Then I can use only
n-1 whole factorial.
So when I can use by 2?
When we can see from both the sides.
And like example in the garland problems are
necklace jewelry.
Necklace problems.
Yes.
Then I can use this problem, this form, n-1 whole factorial by 2. ఇది అర్థమైందండి క్లియర్ గా? నహాస్
అర్థమైంది సార్.
కావాలంటే ఒక ఎగ్జాంపుల్ మీరు చూడండి సార్. అంటే మీకు ఎలా అంటే సర్క్యులర్ పెర్ముటేషన్ సపోజ్ ABCD ఉంది. Seeing this from front appearing like ABC, how it appears like observing from back side?
ADBC.
ABCD. Is it right? Reverse direction. So this I am considering as different circular arrangement as this, because here neighbors are there. Right neighborhood is B, here right neighborhood is D. But if you can see from both the sides, these two appears to be same. So that's why for each circular permutation, there should be one correspondence. Is it right?
Yes, sir.
And these two I should treat it as one when we can see from both the sides. And the total how many cases are there? n-1 factorial. But pairwise we should consider as 1 because we are seeing from both the sides.
Both sides.
So how many total number of ways required ways? By 2.
By 2.
సార్ ఒక చిన్న డౌట్ సార్. సార్ ఇప్పుడు ఈ ABCD అని తీసుకున్నారు కదా సార్ సర్క్యులర్ లో, దాన్ని ఫ్రంట్ నుండి బ్యాక్ నుండి చూస్తే సెకండ్ దానిలో కనపడుతుందని చెప్తున్నారు సార్. అర్థమైంది సార్, అంతే సార్.
And ఇప్పుడు if you have a chance of seeing from both the sides, so total circular permutations are n-1 factorial only.
Yes sir.
So ఇది ఎలా కనిపిస్తుంది? It appears to be same.
Yes sir.
ఎప్పుడు if you can see from
back side, both the sides, then by 2. Yes sir.
ఇప్పుడు నేను ఒక చిన్న క్వశ్చన్ అడుగుతానండి, సింపుల్ క్వశ్చన్. So in how many ways we can arrange 5 members in a circular table?
4 factorial ways sir.
4 factorial ways, definitely. దీన్ని ఇంకా ఈజీగా ఎలా చెప్తానంటే, actually in circular permutation there is no starting point, is it right?
Yes sir.
So randomly choose any one person and keep it on the circle. ఎందుకంటే there is no starting point and there is no end point in the circle.
Yes sir.
అవునా కదా? ప్రాక్టికల్ గా ఆలోచించాలి. In linear permutation, suppose randomly if you choose a person and keeping here, అంటే ఇప్పుడు ఎలా అంటే suppose randomly choose a person and keeping here, we can say this is the second place, is it right?
Yes sir.
And this is the first place. But here in circle it's not like this. So here there are no places.
Yes sir.
And moreover there is no starting point and there is
no ending point.
No ending. So keep the first person here first. Any person, it's your wish. ఎందుకంటే ఆల్రెడీ పర్సన్స్ అరేంజ్ అవ్వాలిగా ఫైనల్ గా.
Yes sir.
Finally they should arrange. Suppose keep any person here. So remaining how many persons are there?
4 sir.
4 persons. Keeping one person arm circle, then the next arrangement, it turns out to be a linear. Circle is also turns out to be a linear, because suppose if you want to keep any person here, then with respect to this person, we can decide whether he is on the right hand side or on the left hand side. Is it right?
Yes, sir. అర్థమైంది సార్.
That's why doing any arrangement in a circle, then the next arrangement linear. ఏమవుతుంది?
లీనియర్ సార్.
సో ఇప్పుడు ఒక పర్సన్ పెట్టేసా, నెక్స్ట్ హౌ మెనీ ఆర్ దేర్? 4 ఫ్యాక్టర్. దట్స్ ఆల్. సో ఇలా కూడా చేయొచ్చండి ప్రాబ్లమ్స్. సింపుల్ క్వశ్చన్ అండి ఇప్పుడు నేను అడిగేది. ఇన్ హౌ మెనీ వేస్ వీ కెన్ అరేంజ్ 3 persons? ఓకే, in how many ways we can arrange 2 persons in a circle in 2 numbered chairs? And in how many ways we can arrange 2 persons question అర్థమైందా?
Yes, sir.
ఏం చెప్పు ఒకసారి.
2 persons in a circle in a 2 numbered chair.
2 numbered chairs.
Yes, sir.
Anyways, usual గా ఏం చెప్తాం సర్కిల్ అంటే?
n-1 అని.
What is the answer?
1, sir.
But that is not correct. ఎందుకంటే what I am saying, number chairs.
Yes, sir.
Suppose this is 1 number chair and this is 2nd number chair. So suppose P1 is here and P2 is here. So it's different from P2 is here and P1 is here. Is it right? అర్థమవుతుందా? Whether they are in the circle or not. So number chairs I am saying. So that's why how many arrangements are there here?
2, sir.
2. So are there 3 persons ఉన్నారు అనుకోండి. In how many? It's nothing but linear permutation. Is it right?
Yes, sir. Yes, sir.
So suppose 3 persons I want to arrange in circle in 3 numbered chairs. And what is the answer?
6, sir.
ఎందుకు? ఇక్కడ చూడాలి. ఇక్కడ ఎగ్జాంపుల్ విత్ ప్రీవియస్ ఎగ్జాంపుల్ యూ కెన్ అండర్స్టాండ్. అంటే ఇవి నెంబర్ చైర్స్ అన్నమాట. దిస్ ఇస్ ఫస్ట్ చైర్, సెకండ్ చైర్, థర్డ్ చైర్. Then this arrangement is not same as that of this. Is it right?
Yes, sir.
By rotating actually, so their places will change. So under total 6 chances we can get it. అంటే రాయండి కావాలండి అది కూడా. Arrangement of n distinct things in n distinct places in a circle is n factorial only. అర్థమవుతుందా?
Yes, sir.
Otherwise, number of ways of arranging n persons in n distinct chairs or n numbered chairs is n factorial. రిమైనింగ్ రేపు డిస్కస్ చేద్దాం మనం. సర్క్యులర్ పెర్ముటేషన్స్ అయిపోయినట్టే మాక్సిమం. ఇంకొక 2 పాయింట్స్ ఉన్నాయండి. మీరు యూ కెన్ స్టార్ట్ డూయింగ్ ద క్వశ్చన్స్ అన్నమాట. ఒకసారి చెప్పండి, సర్క్యులర్ పెర్ముటేషన్స్ లో వాట్ ఆర్ ద థింగ్స్ యూ షుడ్ రిమెంబర్ తేజస్?
Sir, there is no starting point. Number of permutations for
there is no starting point and no end point.
Yes, sir.
అక్కడ దానికి స్టార్టింగ్ పాయింట్ ఎండ్ పాయింట్ ఉండదు అక్కడ, అంతే కదా?
Yes, sir. And for n distinct things we can have n duplications, sir. Number of circular permutations for n distinct objects.
ఆ n duplications కూడా ఎలా ఫార్మ్ చేసి చెప్పే కదా, రొటేటింగ్ ఇట్ we can get.
Yes, sir. Yes, sir. Is n-1 whole factorial. Arrangement of n distinct things in n distinct places in a circular way is n factorial.
n factorial only. But distinct అని చెప్పలేదు అనుకోండి, circle means n-1 factorial only usually.
Yes, sir.
Next, when we can write n-1 whole factorial by 2?
If the circular permutation can be seen from both the sides, sir.
అంటే ఏంటి, ఎలాంటి కేసెస్ లో?
అంటే గార్లాండ్ గానీ నెక్లెస్ గానీ.
అప్పుడు ఏం చేస్తాం?
అప్పుడు ఫ్రమ్ బోత్ ది సైడ్స్ చూడొచ్చు కాబట్టి n-1 హోల్ ఫ్యాక్టోరియల్ బై 2 అని యూజ్ చేస్తాం సార్.
2 different circular permutations we are having.
ఎస్ సార్.
అంతే కదా, ఎగ్జాంపుల్స్ అన్ని మీకు అక్కడ ఉన్నాయండి. అంటే ఏబిసి ఫ్రమ్ వన్ సైడ్ ఇట్ అపియర్స్ యాజ్ ఏసీబీ. సో దట్
Yes, sir.
ఏసీబీ ఆల్సో we are counting as distinct in n-1 factorial.
Yes,
But
sir.
if we have a chance of seeing from both the sides, those two we consider as only one way. But అందుకనే బై 2 రాస్తాం. అర్థమైందా?
అర్థమైంది సార్.
మళ్ళీ ఇంకోటి ఏంటి, ఇన్ సర్క్యులర్ పెర్మిటేషన్ n-1 ఫ్యాక్టోరియల్ వీ కెన్ అండర్స్టాండ్ లైక్ డిఫరెంట్లీ అన్నమాట. ఎలాగా? సో randomly choose any person and keep it on the circle.
సర్కిల్. ఎస్ సార్.
Arrange remaining persons in linear is same as that of number of circular permutations arranging n persons in a circle. నా ఫైనల్ గా ఏంటో n-1 ఫ్యాక్టోరియల్ కదా.
ఎస్ సార్.
How it comes? One explanation నేను చెప్పాను నేను, duplications. And another explanation is keep any person randomly on the circle.
అరేంజ్ రిమైనింగ్ పర్సన్స్ ఇన్ లీనియర్.
Arrange remaining persons in linear. Linear ఎందుకు ఉన్నాం? Keeping
అంటే-
one person.
ఎస్ సార్.
ఒక పర్సన్ పెట్టేస్తే ఏమవుద్ది? In the next arrangement we can decide the person is either right to the already fixed person or left to the
Left
fixed
to the-
person.
ఎస్ సార్.
అంటే like linear arrangement only. In linear arrangement also who is right person and left person. And what is the starting point and what is the ending point? And after keeping one object in a circle, then automatically next arrangement it's going to be a
లీనియర్.
linear. ఎందుకు లీనియర్ అవుతుంది అర్థమైందా?
అర్థమైంది సార్.
లీనియర్ లో నీకు రైట్ లెఫ్ట్ అనే ఉంటాయి.
అవును సార్.
బట్ కీపింగ్ ఫస్ట్ ఆబ్జెక్ట్ ఇట్స్ నాట్ ఎ సర్కిల్.
ఎస్ సార్.
ఎందుకంటే ఫస్ట్ ఆబ్జెక్ట్ కి రైట్ లెఫ్ట్ లేవు పెట్టేటప్పుడు.
అవును సార్.
ఫస్ట్ ఆబ్జెక్ట్ పెట్టేసిన తర్వాత ఇఫ్ యూ వాంట్ టు కీప్ ఎనీ ఆబ్జెక్ట్ after placing the first object in a circle, then we can decide it whether the coming person is right side to the starting person or left side to the starting person అనేది decide it.
ఎస్ సార్.
కాబట్టి then the next arrangement it's going to be linear.
లీనియర్.
How many places are there? n-1 places are there. అంతే కదా, n-1
sir.
factorial.
ఎస్ సార్.
Okay, bye.